burn the microcontroller. But before we actually start with the Keel compiler, let us have one or two more programs in order to give you a more idea about how the programming of 8051 is done. So firstly, we'll see this program in which a switch is connected to pin P1.0 and an LED is connected to pin 2.7. We have to write a program to get the status of the switch and send it to the LED. Now, tell me what should be the first step when you write this program. See, yesterday I told you that any port is either an input port or an output port. Okay? So in order to make it an input port, we have to define it. We have to firstly tell the controller that you are an input port. And how do we do that? Set and clear is for a single bit. Otherwise, if I'm talking of the whole port, we give it FF. That means you have to put a 1 on all the port pins in order to make it an input port, and you have to make a 0 on all the pins in order to make it an output port. But we need not make it an output port because by default all the values are already 0 on reset. So initially, because in this case a switch is connected to a pin P1.0, so we have a single port pin P1.0. You need not make the whole port input port. So what you do is that you initialize the port pin P1.0 as an input bit by set B. Okay, so that will be the first step. So that is how you write your program also. आप एक step जो है, you begin with a single step. So let me write this. Set B. Okay. What next? A switch is connected to pin P1.0 and an LED to pin P2.7. So that means pin number 2.7 is to be made an output, but we don't need to make it. So we need not say clear P2.7. So we have to get the status of the switch. That means P1.0. So that means continuously data is coming from the switch to the pin P1.0. We have to keep monitoring it and we have to send it to the LED. So basically करना क्या है आपने, that the whatever bit, whether it is a high or it is a low, you are getting on P1.0, you are sending it to the P2.7. But we cannot do जैसे हम करते ना move B, A and all, but we cannot do it for single bits of the ports. We cannot say move to P2.7, P1.0. No. Logically, we have to do this thing only, that whatever we are getting on P1.0, it has to be moved or copied into P2.7, but we cannot say move this. So what you can take? You can take a carry bit also, because carry is a bit. Now, this is where most of the programmers do the mistake. What they do is, let's say if I write like this. Firstly, it was P1.0. Which bit was it? 1.0. Okay. Now let's say I'm saying and to which bit is it to be transferred? 2.7. Suppose I write in this way. What is the mistake I'm doing? Yes, because yesterday while saying the various notes on programming, we had seen a very important point, that the source and destination should be of the same size. But in this case, your source is a single bit, whereas the destination is a 8-bit register. So you have to take a single bit as the intermediate, I can say. Got my point? Is it clear? So similarly, I take the carry bit. So what it will do is, Firstly, from port pin P1.0, it will transfer or copy the data to the carry bit, and from the carry bit, it will transfer it to the P2.7. Carry bit is a single which I have taken. You can take any other bit also. Okay, is it clear? One more thing is that now suppose I just write my program here and in the end I say end. That's it. What it will do is, it will only copy the contents at one bit, it will transfer it to P2.7 and end. But suppose I want to do it continuously, because in such operations wherever we say that get the status of the LED or anything, then in such cases it is by default understood that you have to perform the operation continuously. ऐसा नहीं है कि आपने एक बार स्टेटस ले लिया P1.0 पे जो भी आ रहा था उसको कॉपी कर दिया 2.7 पे और खत्म कर दिया. You have to do this operation continuously all the time. So can you tell me what should I do? I have to do loop. अभी loop इस केस में कैसे करेंगे? Just think. कैसे करेंगे? Suppose, yes participants, suppose I want to repeat this particular operation continuously a number of times. So what we can do is, we can make a label. हम यहाँ पे which operation is to be performed starting में, we make it a label again. And after this, instead of this end, I say S jump again. See. Now see the program. This is called indenting. We should always prefer to write our program so that it is more readable. So what it is doing is that once it is transferred the bit to P2.7, when it says sjump again, it goes to here, and then again this will keep on repeating continuously. So it's a forever kind of thing. Okay? Understood? Any doubts in this? No. Now let us come to our second statement. The second statement is that assume that bit P2.3 is an input and represents the condition of an oven. If it goes high, so here otherwise it is implicit. You have to take it by default that it is an input bit, but in this case they have given in the statement itself that assume that it is an input and represents the condition of an oven. So you have connected an oven. You have connected an oven to the pin P2.3. So you have to monitor. Basically what he's trying to say is that you have to monitor the condition of the oven. In case it goes high, it means that the oven is hot. ठीक है? अगर वो bit high हो जाती है, इसका मतलब oven hot है. So you have to keep on monitoring the bit continuously. Whenever it goes high, send a high to low pulse to P1.5 to turn on a buzzer. Now I would want you people to try this program. Just try it. See the statement. Whenever we have to write a program, your statement is the biggest help to you. Just read each statement and accordingly think which instruction is the best suitable for this. For example, initially it says bit P2.3 is an input. So which instruction should you write for this? It should be set B P2.3 because you have to make it an input bit. So your program will start with set B P2.3. And then you have to keep on monitoring the bit continuously. If it goes high, then you have to send a high to low pulse to P1.5. So just try yourself. I'll give you one hint in my yesterday's class also, a similar kind of program I had told you. Yes, our participants, are you trying? Or you have any doubt, you can ask me. Yes, students, If you have any doubt regarding how to write this program or any instruction, please ask me. See. I will write set B, which is the bit P 2.3. Okay. And then what should I do? Okay. What is the operation which I'm going to do? We are going to continuously monitor this bit. And in case it is high, I have to send a high to low bit. So iska matlab, if I make it such that if I say that till the time it is low, keep it here. If it high, it becomes high, go to the next step. So tell me. Okay. J and B. Label बताइए. Let's say here. Jump if not bit P 2.3 comma here. Right. See what it will do is. So what this will do is it will keep on monitoring this bit P 2.3. Jump if not bit means ka matlab, what does it mean? That if it is low, jump to here, and here I've kept here only. So till the time your P 2.3 is low, it will not go to the next step. It will remain here only. And the moment this condition becomes false, the moment your P 2.3 becomes high, what is the next operation I have to do? I have to send a high to low buzzer to which pin? 1.5. So high to low set B P 1.5. So I make it high, and for low I say clear. बस खत्म. And so what is wrong in this statement? In this program, there is one error in this statement.
First time जब ऑटो का program end हो जाएगा वो I to low देने का. मैम फिर से continuously
we have to. In the statement it has been mentioned to you, monitor the bit continuously. So what you have written the program, that once it becomes high, you have given a buzzer. बजर देके भूल गए, सो गए. उसके बाद दोबारा हॉट होता हो गया, उसके बाद बजर नहीं बजाया, a fire. So again you have to continuously monitor it. So S jump. Now what should be the destination of this S jump? Here. So automatically what it will do is that after giving a buzzer, it will again monitor it. Maybe now the bit is low. So then there is no need of giving the buzzer. Now suppose again if it goes high, it will sound a buzzer, and so it will be a continuous process. Understood? Yes, our participants got the point?
Yes, ma'am.
Any doubts?
No, ma'am.
Any doubts in this? No.
What, ma'am?
Okay. So now we'll go to, yes. Okay, so now we have seen the architecture part also. Now we have seen the programming part also. Of course, there are a lot many things which are to be done, but at least for basic programming and basic architecture, now you have an idea of what 8051 is all about and how programming is done. One more thing I want to tell you is that when you're writing a program, this is the structure of a program in which there are three things mainly. One thing is your instruction itself. Instruction is basically, as the name specifies, it is an instruction to the controller what you want it to do. So basically when you convert your program from assembly language to the hex file, now these instructions are converted into machine language. But apart from instructions, there are also some more things. One thing is known as assembler directive. जो हमने लास्ट में end लिखा था एक बार, yes, in the yesterday's class, that end was not an instruction. It was an assembler directive. So apart from instructions, there is another thing which is known as assembler directive. The other name for assembler directive is pseudo instruction. It is not actually an instruction. It is just a naam kya hai iska? Assembler directive. So it is a direction to the assembler that end the program. But when you will convert it into machine language, there will be no machine code for the end. Similarly, in the starting of the program, always write. There is one another important assembler directive, that is org. Now I'll tell you what do you mean by this org. Now in this program, all the others are instructions except org. Org means it's an assembly directive, and it is basically a direction to the assembler that look at the memory location 0h. Now can you think of why we need to give this direction to the assembler that look for the memory location 0h? क्यों easy है? 0 याद करने में आसान है. Why is it easy to make it 0h? या 0 is your favorite number? Partly your answer is right. It may overlap because if you do not define it, it may start from any other location, and that may be an overlap. But one main reason is that we had done one reset pin yesterday. You remember? Reset pin ke baad I had shown you one chart in which there was one table in which it was shown that what is the status of the various registers after reset. I'll show you again. Then we had seen that except stack pointer, the status of all the registers was 0. This one. Now see the reset value of some 8051 registers. Except stack pointer, all the registers are 0. Now what I am mainly interested right now is the status of program counter. What is the status of program counter on reset? 0, 0, 0, 0. Now how is it related to what I was telling you? बताइए. Right. That is the reason. So this is the main reason. That otherwise what will happen is that if you do not specify org 0h, it will take any location and start writing your program. But when writing your program, but while execution, it will take by default address as program counter, because program counter contains the address of the instruction which is to be fetched first. So initially if that value is 0, 0, automatically it will go to 0, 0, 0, 0. If you have not written your program at 0h location, whatever garbage data is kept there, it will execute that. But we don't want that. We want our program to start at 0h because the default value of program counter on reset is 0h. So this was the main reason. Okay. Now coming again. जी. देखो उस केस में आपके दो तरह के रीसेट है. उस केस में आपके दो तरह के रीसेट है. जिस रीसेट की आप बात कर रहे हैं दैट इज पावर ऑन रीसेट. सो इट विल प्रोग्राम काउंटर की बात कर रहे हैं ना, इट विल कंटेन 0, 0, 0, 0. नहीं, आपने एक बार उसको जब रीसेट कर दिया, एवरी टाइम इफ यू गिव इट अ रीसेट, तो यू हैव टू मेक इट 0, 0, 0, 0. You have to make it, because otherwise what will happen is that if the first instruction is executed, if it is 1 byte or 2 byte, automatically the program counter will be incremented by that many bytes. तो वो तब तो वो automatically लेता रहेगा. But once on reset, then you have to make your program at 0h. So like I was telling you about the main structure of a program, one thing is assembler directive, one thing is your instructions, and the third main thing is comments. Comments, although they may not add to your machine language, but they are very important part of your program. When you're writing a small program, it's okay, but when there are large coding, then you should always make it a point to include comments in your program. Okay, what do the comments tell? It tells basically what that instruction is meant to be. And I would suggest that all of you also, whenever you write any program, always include comments in that. That means which this particular instruction, what it is going to do. And how is it done? In case of assembly language program, it is done by a semicolon. So let's say by giving this semicolon, I'm writing make P 2.3 an input bit. So similarly, in the case, the next statement can be made, keep on monitoring it continuously. So whenever this program will be compiled by the compiler, what it will do, the moment it comes across this semicolon, it will simply ignore the next statement, and it will not make any hex file of that. But being a programmer, it increases the readability of your program. And suppose at a later stage you write some code and another programmer takes up the project, so he should be knowing that okay, you have written these steps, what is the meaning of all these steps. Okay, so there are mainly three things in a program, in the structure of a program. One is assembler directive, the other is instruction, the third one is the comment. Okay, any doubts? No. So now we know that once we do the program, let's say in this case we have done the assembly language programming, we cannot write this on the microcontroller. This we have done for our own understanding. So what is the next step? What is the next step? We have to create a hex file. We had seen yesterday, na? I'll show you that slide. In the meanwhile, if you have any doubt, you can ask me. The hex file. It is with the help of a compiler. So the compiler which is most widely used for creating hex file for 8051 microcontroller is Keel compiler. From the centers, I want to ask you, do you have Keel compiler with you? Do you have Keel compiler with you? Because after this session, you will be doing practice session on that. Please let me know if you have Keel compiler. Otherwise, I'll tell you the link from which you can download your trial version.
No, ma'am, we don't have.
Which college is yours?
Ma'am, Asians.
I think I had sent you a link. I had a talk with Mr. Kaushik, right?
Kaushik. Yes, ma'am.
So I had a talk with you that day. I had sent you one link also. Did you not receive that?
Okay, ma'am.
So if you have not received it, I will tell you, in the Google, go to Keel, download Keel trial version.
Okay.
Let me check if the net is working here. I'll show you also. And please download that, because all the programs which we have done till now, I would want you people to make the hex file after this lecture. So once you download the Keel compiler, so you'll get this kind of icon, Keel Microvision 3. So when you go to that link, it will show you various versions. The version which you have to install is C51. C51. You people also can download it. Keel Microvision, download trial version of Keel Microvision, and in that you'll get various different versions. So download C51. The only limitation is the size of the hex file. It is limited to 2 kilobytes, but that is enough for us in order to have an understanding of how the hex file is being created. Okay, so as you can see here, this is the icon for Keel Microvision 3. It's not visible there. Yeah, this is the icon. So I'll simply click. This window will open. Now this kind of window is known as Integrated Development Environment, IDE, IDE of Keel Microvision. Okay, so the first step, you may note down these steps also, because initially when you start working, if you forget a single step also, then you'll not be able to make the hex file. So the first step is create a new project. For that you will go to, why is that not visible, the whole screen? Are you able to see the whole screen, these file, edit, etc.? That's fine. Yes. So this is the integrated development environment I was talking of. Initially go to this project, create new project. So new Microvision project. Simply click on this. It will ask you for the destination. Destination, for example, by default it is showing documents, but you can make any destination. For example, in this case, I'm choosing the desktop. Now, I would suggest that when you select the destination for creating a new project, make one folder there. Make one folder. If you do not make your folder, all your files, they will be scattered. Okay? For example, I make a new folder here and I'm giving it a name. Let's say. So, and in the folder, I'll type my name. And if, let's say I want to make the hex file for a simple program, addition of 2 numbers. ठीक है? तो हम इसको जो नाम देंगे, let's say sum. Okay, so it will save. And also just notice that save as type, it is project file Microvision 2. So I'll save it. After saving it, next window which is appearing here is asking you select device. It is very important in this case that you choose that controller on which you are actually going to work. Because हम assembly language में program बना रहे हैं, so it is specific for the controller. So suppose I am going to work on Atmels 8751. So what is meant by 8751? 80 stands for Atmel. Let's say C stands for CMOS technology. 51 to 8051 का है. And what is the significance of that 7? 8751. What does it mean? What is the memory type? No, flash is for 89. 7 is for UV EPROM. So let's say I'm making 89C51, that is flash memory. So it will also give you all the description of the type of microcontroller. How many interrupts are there, how many timer counters are there, what is total on-chip RAM, in this case 128 bytes, 4 kilobytes of flash memory. All the description also it's giving me. So I'll simply select this and say OK. So at this step, you should be aware of कि आपने कौन सा controller use करना है. Only choose only that controller, because if you will not choose the right controller, when you actually burn the controller, then it will give you a communication problem. And then it will say copy standard code. You can either say yes or no, it doesn't matter. So in this case, I'm saying no. So just see here, this project workspace. Earlier it was empty. Earlier this was empty, but now a target has been created here. See, a target has been created here. Okay. So this was the first step. Whenever you want to create a hex file, the very first step is how to make a project. So you have to make a new project, make a destination, and then select the destination, make one folder there, give it a name, and whatever project name you want to give, then it will ask you which type of microcontroller you want to choose. You have already chosen, and then you will check in the workspace that it has created a target. Now I want to write the program to which I have to create the hex file for. So at this stage, this window is disabled. So I have to make a new program. So either you can choose this icon, or you can go to File and say New. So this kind of window will open. So it's blinking, that means it's ready for you to write. Now suppose I start writing my program. So it's always advisable to start your program with a comment which tells us that what is this program going to do. So let's say I say program to sum two numbers. Now tell me, what should I write? बताइए, 2 numbers के लिए program. वाजी बताइए. 0h, yes. Move a comma. So if not put the hash, that means you're going to copy the contents from a memory location. So that you have to put a hash. So 25h, let's say. That's my favorite number. So this is, I write a comment, copy 25h into accumulator. So what should be the next step? You need not move the second number into some other register. Simply add a comma hash, let's say 32h. So add 32h to accumulator. Then end. So now I have written my program. My next step is to convert it into the hex file. So the first step will be save this program. So either you can use this or you can go to file. So I'll simply say save. So when I'm saying save, automatically it is choosing the destination of the folder which I had created. So that's why I told you that create one folder. If you do not create it, it will simply scatter all these files on the desktop, and it will be difficult for you then to recognize where is my linking file, where is my object file, and all those things. So already in the folder it is showing my project name as sum.microvision2. So let's say I give it a name add. Now here you have to keep in mind one thing, that whenever you save the name of your program, you have to give it an extension of whether it is an assembly program or it is a C program. So because in this case the program is in assembly form, so I'll give it an extension .asm. Otherwise, if it was in C, I'll have to give it an extension .c. Okay. So save. It has been saved. Now looking into this program, can you see one difference? See, all these things, comments are in a different color, your data is in a different color, and your commands or your instructions, opcodes, they are in a different color. So this is a beauty of Keel compiler. What will happen is that, let's suppose by mistake I had written some instruction wrong. All the instructions are bold black. Now let's say it was a small program, so it doesn't make any difference. I can easily make out that yes, I have made my mistake. But when it is a very large, you have written a very large code, then sometimes you make such kind of mistakes and it skips that. Yes. So when you will save this, automatically seeing at the program, you can say that, oh, there is some mistake in this code. Why is it not bold and black? So you can immediately rectify it. Okay. So once you save the program, the commands will be in different color, the instructions will be different color. Now what is the next step? Yes. It is not case sensitive. You can write your program either in capital or you can write your program either in small. It doesn't make any difference. So yeah, next step, very important step. Once you have saved your program, then go to this project workspace, and in the source group 1, just and say add files. See, all these things which I'm telling you, you will not find in the book. You will not find in the book what are the various steps of creating hex files. So that's why I'm telling you that be very conscious about ध्यान से ये समझिए, and then you can try on your own also, because the code for Keel is available free in the internet. Now when I'm saying add files to source group 1, then in the folder, why is it not showing my file though I had saved? Just see. Yes, can anyone tell me? See, I had already saved my file as sum in the folder Ritula, but it is not showing it here. That is because by default file of type is chosen as C source file, whereas my file was in assembly.asm. So from here I will change it to .asm, so it is showing it now. Add.asm. Okay, so I'll simply select it, add, and then close. Now I'll check again in the project workspace, in the source group it has been added. So this step is very important. Adding the source code or adding your program file to the source group. So now I'm ready to decode my program. So I'll just check if this program is without error, because until and unless your program is without error, it will not create hex file. The compiler will not create hex file. Just like you work in C also, आप उसको run करके देखते हैं ना, until and unless it is without error, it will not work. So similarly in this case, in order to run it, you'll go to here, translate current file, this icon which you can see here, translate current file. So this is known as the output window. There are basically 3 windows in this. This is the project workspace window. This is the window wherein you write your program, and the third window is the output window, which gives you the output of the command whichever you have given to the program. So what after assembling, what is it showing? 0 errors. So until and unless you get this 0 here, it will not create your hex file. Now let's say I made some mistake. This was the program, let's say I had written. So what is the error in this? What is the error in this program? Data is 16-bit. So register is destination register is 8-bit, whereas your data is 16-bit. So it should give an error. Let us check. Value has been truncated to 8 bits. And another thing is that, let's say, now let's say it's showing you one error. Another thing is it's telling you where the error is in the line 4. See, it is automatically numbered all your code. The line 4 there is one error, and the type of error it is also telling you that syntax error. The error is syntax error. So suppose you select here, so it will also point you. It will take you to that particular line. So when there are very large lines, so when there is a very large program, in that case it's very helpful. Keel compiler is a very user-friendly kind of compiler. So when there is a very large program, you have made some code syntax error. So when you select that, take me to that error, automatically it is pointing also here. That see this pointer. But this is the source of your error. So I simply.
What is the significance of warning?
Okay, in case of warning, it doesn't matter. You may go ahead with your compilation, because warning mostly it will be not related to the hex file. It will be like, suppose I have not given it your assembler directive org 0h or end, because in that case anyways it has to convert the hex file from the instructions. It is not concerned with your assembler directive. So it will go ahead, but yes, this error should not be there. But yes, of course, warning, as I told you, that assembler directive is for us. It will compile in that case. It will compile any kind of garbage data there is there, but we don't want that to happen. So always make sure that it is 0 error and 0 warning. So now I've rectified the error and I again run it. So it is 0 error. So now I'm sure that there is 0 error. Now I can create the hex file. Now what is the next step? I again go to project, options for target. project, options for target, and in that I go to output. So the sum of executable means this is the hex file. You can change its name also. By default, the hex file's name, it is taking the same as the main file you had created. Now it is this create hex file is unchecked right now. You can check it here. Okay, you should check it here and then say okay. Now once you have create hex file, again go to translate current form and next build target. So see the output window, creating hex file from sum, and sum has been created. That means your hex file has been created, which is ready to be downloaded now to the microcontroller. And in case you want to see your hex file, you can see. So on the desktop, I had made one folder in which all my files are there. So there are various steps: list file, object file, linking file, all these. See, it's not a single like आपने assembly में लिखा और उसने directly hex में create कर दिया. This basically goes through a number of series of steps. But what we are mainly interested in this hex file. It is written here also. See, hex file. So I simply, if you want to check this, so it is showing you in the binary form or the hex form. So if you were to write your program in a machine language, आपको ऐसा program लिखना पड़ता था. So now it has made the thing so simple for you. You simply write your program either in assembly language or C language, and you simply convert it in the hex file. And then this can be then downloaded to your microcontroller using the Super Pro programmer or a universal programmer, or it can be a flash programmer also. Alok di dena ho. So any doubts in this on how to create hex file? See, in the book you will get to know the things about the architecture. In the book you can get to know the thing how to write a program. But when you are actually working on a project, what main matters is how you transfer it to the microcontroller. So the very first step is to create a hex file. Should I repeat these steps once? I'll repeat it for your convenience again. See, initially we go to this icon, Keel Microvision 3, and I'm clicking this, a kind of IDE, integrated development environment comes. Then you say project, new Microvision project, and when it says new Microvision project, it asks you one destination. You create one destination folder, give the name of your project, and then you save it. Then write new file में जाके new, तो ये window हो जाएगी, यहाँ पे आ जाएगी, और window में आप अपना program लिखिए, save the program, and then main point is go to source group 1, right click this and add files. That is very important. So यहाँ पे आप जब देखेंगे तो add.asm आ गया आपका. Then you translate, means you run it to check for if it has got any error or not. Then until and unless you don't get 0 error, then you will not be able to create the hex file. So once you get the 0 error, again go to project, options for group, source group 1, options for target. उसमें जाके again go to output and check this create hex file. Okay, and again when you say this second icon now, build target, you will get your hex file here. Okay, so this is how अब hex file हमने बना लिया. Next step is to burn this into the microcontroller. Now for burning this there are two options. One kind of burner is your universal programmer, which I have with me now. So this is the universal programmer. Now this can be of different companies. For example, I have from Unipro 110. So why is it called a universal programmer? Because any kind of IC or any kind of controller you can put here and you can burn it. Burn means burn the programmer. So This is the programming cable for this. As you can see here, this is the programming cable. It's a USB basically, which you connect to your USB. Please connect this to the, and this is its supply, power supply. नहीं ऊपर रखते एक्चुअली इसका USB इस तरफ है लैपटॉप के अंदर आप लगाइए okay. Actually, it comes with a software of its own. So right now I'll have to install that software. It will not be possible right now, but I'll just tell you that firstly you have to install your software of this Unipro into your in your laptop or your PC, and you connect. इसको निकाल दीजिए अभी रहने दीजिए इसको. And then you connect your universal programmer with your PC through the USB port, and after that what you do, a window just like Keel compiler, a window will come, an ID will open, and then it will ask you for the option that select the destination for the hex file. So you just select the destination, you select the microcontroller on which you have to burn, और main ये है कि आप इसमें lock दिया हुआ है, you can see here. So this is a lock, this is a lock. So you simply insert your controller into this, you have to lock it first, and then through this programming cable you simply download the hex file into this. So this is one kind of burning of the program into the microcontroller. But in this case what happens is that every time you have to take your controller out of your application, put it here, burn it, and then put it again into your board. The other kind of programming which you will be seeing also on Friday, that is in-system programming. In case of in-system programming, you need not take out your controller out of your board. You simply connect your application board to your PC, and through the flash programming you can directly burn your code and erase it also. So that is the second kind of programming you do. Okay, but at this time I wanted to show you that how the programmer actually works at, or else in that Arduino class you're going to tell them, no? So tomorrow we have one class at 11:30, then you will get to know that how that in-system programming is done. So for the centers, actually I have one announcement that at 11:15 this there is one function in this studio. So in your timetable also we have kept the practice task for that time. So that is why we don't have much of the time for showing this actual burning, but I've told you that how the things work. Basically you have to connect it to the PC and directly you burn it, selecting the destination. So I have an announcement for all the centers that after this class, for the next session from 11:15 to 1 o'clock, there is a practice session. So whatever programs we have done in the class yesterday and today, please try them on Keel, try to make the hex file, and that will be a practice session. And then in the afternoon class, we have an expert lecture. Before that, for some time, let's say 15 minutes, we will be discussing if you have any doubts or you faced any kind of problems by creating your hex file. Is it clear? All the centers? एक एक करके कनेक्ट करवा दीजिए. एक एक करके कनेक्ट करवा दीजिए. ठीक है, ओके. Yes.
ओके मैम.
एक एक करके सेंटर को कनेक्ट करा दीजिए. मैं एक एक करके सेंटर को कनेक्ट करा दीजिए.
Ma'am?
जी.
Ma'am, we will meet at 2 o'clock then, and we will ask
Yes.
if any will be there.
Yes, Puneet. अभी आप मतलब actually at 11:15. Otherwise, also there was a practice session. So
Okay,
I
ma'am.
hope you are able to know how hex file is created and all those things. So whatever
Yes.
programs we did yesterday, please practice them in this class. And at 2 o'clock we'll again then meet and we'll discuss if you had any problems.
Okay, ma'am. No problem.
Okay. Okay. Please connect some other center. Asians. Asians group.
Yes, ma'am. Ma'am, actually, your voice was not audible.
Okay. Okay. I wanted to tell that at 11:15. At 11:15 there is one function here in ETV studio. So otherwise also there was practice session. So whatever programs we have done yesterday and today, please practice them on Keel. Try to make hex file out of them. And in case you had any problems for creating the hex file on Keel compiler, we'll discuss at 2 o'clock today. We'll meet again at 2 o'clock because there is one expert lecture. So before starting the expert lecture, we'll discuss for around 15 minutes if you had any doubts or any problems while creating the hex file. Is it clear?
Okay, ma'am.
Okay.
Yeah, ma'am. Yes.
Okay.
Yeah.
Okay. Any other center? Rameshwaram Institute? Rameshwaram Institute, were you able to listen when I give the announcement about the next class? So in this practice session, please practice on your own about the Keel compiler, which I just told you right now. And again at 2 o'clock and discuss if you had any problems. And also we have one expert lecture also in embedded system practical aspects from industry. Okay. Any other center? Jaipur Engineering College? Jaipur Engineering College?
Yes.
Were you able to listen to the announcement I made about this class, about the practice session?
Yes, yes.
Yeah. So again, we'll meet at 2 o'clock. In case you have any doubt, please let me know. There is one expert lecture at 2 o'clock. Okay?
No.
That's it? Okay. Thank you so much.